Hello everybody. In this video we are going to apply our CAM toolpaths to our model of our crank that we created in our last video. So to start up we need to create our setup. What we'll do is we'll right click, click new setup, and inside here we are going to create some stock that's going to be a fixed size box. So we're going to have a little extra stock on this one, so it's going to take some extra facing on this because the stock that we have is 1 inch by 2 inches. So the width that we're actually going to be using for this is going to be 1.5 inches, which will fit that way. Our depth is going to be 1 inch, but our height is actually going to be 2 inches. So what we'll do is we'll actually cut our part off of the bandsaw like this, and we'll set our piece up on end. So then what we want to do is we want to make sure that most of our stuff will get taken off in our facing operation. When we actually machine this out, it's going to be in this orientation. So before I start selecting our position inside our stock, what I want to do is I want to go back to our setup, and I want to actually flip the orientation of our work coordinate system. So what I'll do is I will select my X or my Z axis and plane, and we have it set almost right, but what I want to do is I want to flip my Z axis. So after I selected my select Z axis, plane, and X axis, if I hit flip my Z axis, and then the last one is I want to flip my X axis, because we want to have our Y going up, our X going to the right, and we want to have our the shaft of our crank closer to us like that. So the last thing that I want to do is I want to change my stock point to the top left corner right there. So what we'll be doing is we'll be putting this into our vise of our mill like this. We'll be taking off quite a bit from the top to be able to get down to our model. Now, as I said, we want to bring this down a little bit into our actual part because we want to take as much off in our first facing toolpaths. So I'm going to go back to my stock, and my model position is not going to be in the center. I want to offset from the bottom, and we are going to have an offset of 0.25. So we just want to have a 1/4 inch up from there, and that will give us enough so that when we flip it in our soft jaws, we'll be able to machine off the top of there. So once we have it set up like this, we'll press OK. And the first thing that we want to do is we want to have a facing toolpath. So I'm going to go to 2D, select face, and for my tool, what we'll do is we go to the RFHS tool library, and I'm going to select tool number 1, our 1.5 inch face mill. Select. And remember, for this one, we're just going to keep with our defaults. Spindle speed of 4,000. Our cutting feed rates for our rough is just going to be 20 inches a minute. Go over to our geometry, and that'll be all right. We go to our heights, and because things are a little bit goofy, we're going to keep the retract height nice and high. Our clearance height, our retract height, and our top height, we're going to be going off of our stock. And for the bottom height, we just want to make sure that we're going off of our model top. So as it stands, we are pretty good right here, and we want to make sure that we are machining from this all the way down to the top of that. So for our passes, what we want to do is we want to have multiple depths. I missed one. First, our pass direction, we want to have that at 180 degrees. So we come from the left side and come in right there. Direction will be both ways. We want to make this as nice and quick as possible. Now we'll go down to our multiple depths. And for our maximum step down, we want to have a step down of 30 thou or 0.03. So when we're done with that, we'll press OK. And there we have our facing toolpaths, and that will hog off quite a bit of the top. Alright, the next step that we are going to do is we are going to rough out the shaft for our crank. So to do that, we're going to come up to our 3D toolpaths and we are going to select our adaptive clearing. For our tool, we are going to select our from our RFHS tool library, we are going to select tool number 3. And before we continue, what I want to do is I want to right click on it and I want to select Edit Tool. Because the cutter that we actually have for that is a full inch for our flute length, and we need to stay down as far as possible, and if we leave it as is, we will be getting an error, or not an error, but it will be a warning when it pops up. So we are going to change our flute length to match our bit of 1 inch. So then we'll accept that. Hit select, and for this we are going to keep our spindle speed at 4,000, our cutting feed rate at 20 inches a minute. Go over to our geometry. We want to select this bottom edge right there. We'll go to our heights and we'll leave everything at default because we did start off with such a excess amount of material. For our bottom height, I'm going to select my selection right there. Click on that top face. For my passes, my optimal load, I want to have 0.0125. And then for my maximum roughing step down, I want to change that to 0.8. For my stock to leave, I want to leave 5 thou, both radially and axially. And all of this looks good. We'll press OK. And there we have our roughing toolpaths. So next thing that we need to do to be able to clean this up is we are going to go back to our 2D and we are going to select our 2D contour. And again, we're going to stick with that tool number 3, that 3/8 inch flat end mill with a spindle speed of 4,000. Our cutting feed rates of 20 inches a minute. The geometry that we are going to select is going to be that bottom edge again. Come to our heights, and again we're going to leave everything the same. The only difference is that for our top height we are going to do the model top, and then for our bottom height I'm going to use my selection and select that top face. For my passes, I'm going to have a finish feed rate of 15, and then I am going to have roughing passes with a maximum step over of 0.35, and for my number of step overs I'll just put 2. For linking, that all looks good. And what's going to wind up happening is this will come down and this will take a pass, and not only are we doing a finish pass to clean this edge up, but we'll also be taking a finish pass on our face right here. So to show what that looks like, we'll simulate that, and it'll come in and we'll take off that 5 thou material that we have remaining from that previous one. And it'll slowly just taper its way in, just like that. So that looks fantastic. The next step that we want to do is we want to do a 2D contour around the spline that we have there. So I'm going to come to the top, 2D contour, and again, our tool number 3, we have all of our feeds and speeds that are going to be the same. The geometry that we are going to be selecting. What we could do is we could run by selecting each one of these, but that would take a bit of time and we run the risk of messing up a little bit. So instead what I'm going to do is I'm going to select this top edge right here. Please do not select that edge, otherwise you will be cutting away material that we need for our chamfer and you'll be undersized. So we need to select this bottom edge right here of that chamfer. And when we click that, so that's going to be our chain, our heights, again, retract, stock top, our feed height will be the top height. The top height right here will be from our model top, and then our bottom height is not going to be our selected contours, it's going to be our selection, and we are going to choose this flat surface right there. If we were to choose our selected contours, it would think that this is the bottom, but we actually want to mill all the way down to that edge right there. So that I come to our passes, my finish feed rate needs to be 15 inches a minute. We're not going to leave any stock or anything. And this all looks pretty good. We'll press OK. And then, if we are to simulate that, we can see that that mill bit will come in and take care of that spline really nice for us. Alright, the next thing that we want to do is we are going to go and we will rough this part out and finish that up, and then we'll come back and we'll do our two chamfers over there. So I'm going to go to my 3D adaptive clearing. We're going to stick with that 3/8 inch end mill. And again, same thing for all of our feeds and speeds. My geometry, I'm going to select the bottom contour here. We need to take care that we select this one right here, because we have a chamfer drawn in for the other side for our op2, but we can't select that. We need to make sure that we select this one right here, the outermost. If we accidentally select that, again, we're going to cut off too much material. Our part will be undersized and we won't have enough material for that chamfer. So we want to select that edge. Our heights, we are going to stick with that. Our top height is going to be from our model top, which is right there. Our bottom height is going to be from the model bottom, but we want to offset that negative 0.01. And what that's going to do is that's just going to go into the bottom a little bit, 10th, so that we are able to face off back to that when we get to our second operation. So then for our passes, what we want to do is we want to have an optimal load for our 3/8 inch mill bit at 0.0125. And then our stock to leave, what we'll do is for our radial and our axial, we'll go 5 thou again for everything, 0.005. And our linking looks good right there. We'll press OK. And as that calculates, you'll see that we come down and we get that just fine. To do our finishing toolpath on there, I'm going to go to 2D. We'll go to 2D contour. And again, for this one, we want to make sure that we are selecting this outside. Please do not select that bottom one. For our heights, again, top height, we're going to go from our model top. Our bottom height, we are going to go to model bottom. However, we are going to offset it at negative 0.01. We're going to go 10th thou into there. Our finished feed rate is going to be 15 inches a minute. And then that all looks good, just like that. Now the last thing we have to do is we are going to chamfer the top here as well as this. And we have two different methods for this chamfer. In this model, this one right here has been modeled in, and this one has not. So if we click off and we look in here, this has that 0.01 chamfer already modeled into it. This one does not. However, on our prints, it reads that we need to have a chamfer there. So we're going to show you how to do both a chamfer like that and a chamfer like that. So to start off, we go to 2D contour. The tool that I'm going to select is tool 23, which is our 1/4 inch chamfer. I'll select that. Spindle speed, again, 4,000. Our cutting feed rates is going to be 20 inches a minute. For our first one, On the top, the contour that we are going to select is the very top edge of that. For our heights, we want to have our top height be the model top, as well as the bottom height be our model top. So when we're doing chamfers, we want our top and our bottom to both be, that model top is going to be at 0. So then we're going to go to our passes. We come down to our chamfer, and because our chamfer is already modeled in here, we're going to have a chamfer width of 0. We'll see later when we chamfer this one, when we don't have it modeled in, it'll be a little bit different. But when we do have the chamfer that's modeled in there, we need to have a chamfer width of 0, and our chamfer tip offset is going to be, for this one, we're going to go 0.05. And what that will do is that will bring in our tool, and the tip of that tool will be down below this 50 thou. And the reason we want to do that is we want to preserve the tip of that tool, so we want to use the side of the cutting tool rather than the very tip. So the rest there looks pretty good. Go to linking, that all looks fantastic, and we'll press OK. And we'll just show you when we simulate, or when we bring this in, we'll come down and we'll see from the side. So we see that the tip of that tool is 50 thou below the very top edge, because we don't want to cut right on that tip, otherwise you risk burning that up or damaging the very tip of that chamfer bit. So we're good there. The next step, and the last step for this operation, is we want to chamfer one of these where we don't have that chamfer modeled in there. So we'll go to our 2D and select 2D contour, and now I'm going to select that top right there. So again, for our tool, it's tool 23, spindle speed of 4,000, cutting feed rate of 20. Geometry, we're going to be selecting that. Our heights, again, because we have so much material there, all of those are going to just stay the same. Our top height is going to be the selection, and we are going to select that face right there. And then our bottom height is going to be the same as that right there. So then we'll go over to our passes, and our finished feed rate, 15 inches a minute. Our chamfer width. Now, because we do not have this one modeled in, we need to tell Fusion exactly how wide of a chamfer that we are going to be using. And the callouts for on the prints are 0.01 or 10 thou. And for this one, we are actually going to have a deeper chamfer tip offset, because right here, if we bring that 1/4 inch chamfer bit all the way down and only have a 50 thou, we run the risk of running our bit into this shaft right here. So what I'm actually going to do is I'm going to do a chamfer tip offset of 0.11, or sorry, 0.11. Okay, and when we go to our linking, that should all be good. We'll press OK. And what you'll see is that when we run this, we'll simulate it. It's going to come in, and instead of getting lower on it, or sorry, instead of being higher on that, we're actually going to be quite a bit lower as we run around that edge. How the math works is from the point, we'll pause that, the point from there to there is 0.125. So what we're doing is we are getting as absolutely low as possible to try keep this bit away from this edge, so we don't run the risk of running our bit into that edge right there. So when we're done running that, what we can do is we can exit that, and you have your part all programmed. What we can do then is we can go and save this, post-process it, and bring it to the mill to be machined out. Next operation, what we'll do is we'll talk about how to place this in our soft jaws and how to machine off the other side. So we'll see you in the next video.